Welcome to This Explainer. Today we're diving into something that's literally reshaping how we interact with information, Google Gemini. If you've been tracking the AI space, you already know Gemini isn't just one single product. No, it's a massive, incredibly complex ecosystem of artificial intelligence models. Today, we're going to peel back the layers and look closely at its architecture, its history, and its very real-world impact. Let's dive right in. Here's our roadmap for today. We'll start with the birth of Gemini, meet the Gemini family, take a look under the hood, talk about the wild nano-banana phenomenon, and finally do a much-needed reality check on its known limitations and safeguards. But before we get into the timeline, I really want you to think about this central question. How exactly did Google build an AI that can see, hear, and speak all at once? Historically, large language models were strictly text in, text out. But Gemini? It was designed from the ground up to be totally different. It represents a fundamental shift in computing, and understanding how they achieve this is going to make everything else we talk about today click right into place. All right, part 1, the birth of Gemini, an AI arms race. Just think about the sheer speed of this timeline for a second. In May 2023, Google first announced Gemini at their I/O conference, hyping it up as a powerful successor to their older models. By December 2023, just months later, they officially launched the 1.0 version. Fast forward through a total flurry of updates, and by December 2025, they were already rolling out the advanced 3.0 series, just to keep up with intense competitive pressure. And zooming all the way to July 2026, we see the release of the highly optimized 3.6 flash and 3.5 flashlight models. The breakneck speed of this development is honestly unprecedented. It's an arms race where the finish line just keeps moving. To pull off this kind of speed, Google had to make a massive structural change. They basically smashed together two of their most prestigious and historically very distinct research branches, DeepMind and Google Brain. This merger created Google DeepMind. They even brought Google co-founder Sergey Brin out of retirement to act as a core contributor, which is huge. By unifying their top minds and tapping into their massive tensor processing units, they built this powerhouse model specifically designed to eclipse competitors. Moving on to part 2, meet the Gemini family, tiers for every task. To clear up the whole naming convention thing, because I know it gets confusing, this ecosystem is cleanly broken down by real-world use cases. At the absolute top, you have the Ultra tier, or in the newer iterations, what they call the Deep Think models. These are built for highly complex, really intensive reasoning tasks. Next down is the Pro tier, which is your workhorse, designed for a wide range of general tasks. Then we have Flash, optimized for sheer speed and native multimodality. And finally, the Nano and Flash Lite tiers. These are the most lightweight, built specifically for on-device, latency-sensitive tasks, like running directly on your smartphone. Basically, Google built a specialized tool for every level of computing you could possibly need. Now, the crucial point here is scale. 10 million. Just think about that staggering number for a second. With the introduction of Gemini 1.5 Pro, Google unlocked a context window capable of processing up to 10 million tokens in their production API. What does that actually mean? It means the AI can hold and analyze entire libraries of books, hours of video content, or massive code bases all at once in its working memory. It completely changes what you can ask an AI to do in a single prompt. We're talking about a shift from a simple chatbot to a comprehensive, heavy-duty data analysis tool. Which brings us to part 3. Under the hood, how Gemini learns. The real secret sauce is this word right here, multimodal. Unlike older language models that were trained purely on text, Gemini was built from day one to be natively multimodal. Its training dataset consists of web documents, books, code, images, audio, and video data. And the crazy part is, it can interleave these inputs in any order. You can ask it a question using a video, an image, and a block of text all at the exact same time, and it processes them simultaneously. This is its absolute core differentiator. So, how does it actually learn to do this? It boils down to 4 major steps. First is pre-training, where the model just absorbs massive amounts of filtered data to learn patterns and predict the next logical word or sequence. Second is post-training, where it's fine-tuned for quality. Third is generating responses to your actual prompts, sometimes using retrieval augmentation, like quickly searching Google to get the freshest data. And fourth is human feedback, where human evaluators assess those responses to continuously improve the model's accuracy over time. That second step, post-training, involves something called supervised fine-tuning. The source material has this brilliant analogy for it. It's like teaching children to write by showing them well-written stories and essays. You don't just teach the AI the basic grammar rules, you show it exactly what an excellent answer looks like written by an expert. The AI learns to mimic that high level of quality in its own responses. All right, part 4, the nano banana phenomenon, a viral hit. Nano banana sounds completely ridiculous, right? But it was actually the internal code name for Gemini's 2.5 flash image generation models while they were undergoing secret public testing. The quirky nickname originally came from a DeepMind product manager, but when this model went fully public, it allowed users to easily create photorealistic, highly consistent images, and it sparked an absolutely massive viral craze on platforms like Instagram and X. People started turning their selfies into these photorealistic 3D figurines that looked exactly like actual plastic toys. In the scale of this viral hit, 200 million. That is a number of image edits facilitated by this model within just weeks of its launch. Weeks! It brought over 10 million brand new users straight into the Gemini app. It perfectly illustrates how a totally abstract, incredibly complex piece of technology can suddenly intersect with mainstream pop culture when you just give people an intuitive interface. Of course, with that kind of immense generative power comes a very real responsibility. When an AI can generate perfectly photorealistic images, how do we know it's even real anymore? Well, Google's answer is Synth ID. It's an invisible digital watermark embedded directly into the pixels of AI-generated content. It's totally imperceptible to the human eye, but it allows specific tools to identify that the image was artificially created. This is absolutely crucial for combating things like deepfake and misinformation. That leads us to our final section, Part 5, Known Limitations and Safeguards, a reality check. Look, large language models are definitely not flawless. The source material outlines 6 core areas of continuing research into Gemini's limitations. First is accuracy. It can and will confidently invent inaccurate information, often called hallucinations. Second is statistical bias in its training data. Third, it sometimes struggles to balance multiple perspectives on subjective topics. Fourth, persona. It might incorrectly suggest it has personal opinions or human emotions, which it doesn't. Fifth, false positives and negatives in its safety filters. And finally, it remains vulnerable to adversarial prompting, where users intentionally try to bypass its guidelines with really complex, tricky inputs. You really see the AI struggle with its own rulebook when you look at safety failures. A false positive is when the AI is way too strict, misinterpreting a completely reasonable prompt as inappropriate and just refusing to answer. A false negative is the exact opposite, when the AI fails its guardrails entirely and generates an inappropriate response despite the safety guidelines being right there. Finding that perfect balance so the AI is actually helpful but still safe, that is an incredibly difficult ongoing challenge. And Google actually acknowledges this reality head-on. Their own overview document states, Gemini is not a magical black box. It's constantly evolving, and we will continue to share updates on our progress. I think this really emphasizes the iterative nature of this tech. It is very much a work in progress that learns and adapts through red teaming, rigorous safety checks, and massive amounts of human feedback. So we are left with a ridiculously powerful, multimodal technology that can process the world a lot like we do, through text, sight, and sound. But it requires our constant vigilance and feedback to remain safe and functional. I want to leave you with this final thought. As AI tools increasingly blur the line between human and machine, how will society actually adapt to our new multimodal assistants? Are they just going to be tools we control, or will they fundamentally alter how we interact with the digital world? Thank you so much for joining me on this explainer, and keep questioning the technology shaping our future.